Okay, we need to go ahead and take these limits. And L'Hopital's rule says we can do the derivative of the top over the derivative of the bottom and then do our limit, but we can only do that if it's an indeterminate form to begin with. You always have to check to see if it's indeterminate first before you can use L'Hopital's. So we're looking at our limit as x approaches infinity. We go ahead, plug in a really, really big number here, e to a really big number, ends up being really big over really big. In other words, it's infinity over infinity, which is indeterminate. So that means we can do L'Hopital's. We can take our limit as x approaches infinity, derivative of the top over the derivative of the bottom. Derivative of e to the x, remember, is e to the x times the derivative of the exponent. So that's why there's a 2 hanging out on the bottom. So now we can go ahead and use L'Hopital's, derivative of the top, derivative of the bottom, plug in our infinity in the top, infinity in the bottom, and in this case we get infinity over infinity again, which means we just have to continue doing L'Hopital's since it's another indeterminate form. So we do the derivative of the top over the derivative of the bottom would be an e to the 2x times another 2, so we get a total of a 4 in front of the e on the bottom. Now we plug in our infinity, we get 6 times infinity, which is infinity, over infinity, which is indeterminate again, so we then do L'Hopital's again, and we're going to go ahead and get 6 over this. Then we go ahead and we plug in infinity. Well, it's just going to be a 6 on top. And then we get infinity on the bottom. 6 over infinity is not indeterminate. So then you got to think, okay, a number divided by something extremely big. Any number divided by something extremely big is essentially close to 0. Well, let's go ahead and take our limit here. We take and plug in 0 for x. We get e to the 0, which is 1. 1 minus 1 is 1. Or 1 minus 1 is 0. Sorry about that. I can't even do simple arithmetic. Then we take 0 and plug it in. Tangent of 0. Oh, you're supposed to have that memorized. So you get 0. So you get 0 over 0. Huh. That's an indeterminate form, which means we could do L'Hopital's rule, which says derivative of the top over derivative of the bottom. Derivative of the top would be a 2 e to the 2x. Derivative of the bottom, derivative of tangent is secant squared. Now, this does simplify a little bit. Dividing by secant is like dividing by 1 over cosine squared, which instead of dividing by a fraction, you multiply by the reciprocal. So it's really multiplying it by the cosine squared. Now if I plug in 0, I get e to the 2 times 0, or e to the 0, which is 1. So I get a 2 times a 1. Plug in 0 here. Cosine of 0 is 1. 1 squared is 1. So that's why we have another 1 here. And 2 times 1 times 1 is just 2. So we get 2. Taking a look at this one here. Try plugging in 0. You get cosine of 0, which you know is 1. Squared that is 1. 1 minus 1 is 0. Over 0 squared, 0 over 0 is indeterminate. So we could do L'Hopital's. However, you could go ahead and remember that 1 minus cosine squared is a trig identity. Ah, we have that basic trig limit showing up, except everything's being squared now. So we could go ahead, separate it up, because sine squared is sine times sine. So we can go sine times sine over an x times an x. Then we can go ahead and use our basic trig limit. However, remember what we have after our sign on top has to match what we have on the bottom. Oh, we don't have that, so we'd have to put a 2 here in front of the x on the bottom. And if I put a 2 on the bottom in front of my x, I'd have to put a 2 in front of my sign. So if I put a 2 here, I got to put a 2 in front of my sign. Same idea here. If I put a 2, so it matches what's after my sign on the bottom. If I put that 2 there on the bottom in front of the x, I got to put a 2 in front of the sign. So what I have for my basic trig limits, we know that my basic trig limits, which are boxed in red here, are going to be 1. So we have a 2 times a 0, or 1 times a 2 times a 1. So in other words, we just get 4. The last problem here, lots of mumbo jumbo trying to get you lost in all the words, but go ahead and try to work through it. Pause it if needed. Basically what they're saying is to take this limit right here. If the limit of the top, limit of the bottom are both 0, it's indeterminate. It's saying to take this, if we get 0 over 0, we could use L'Hopital's, which says we get this. So basically it's saying to be able to take the limit of this, all you do is apply L'Hopital's and you get answer C.